The purpose of this lab is to observe the fundamental theorem, Newton's second law, on a system moving at constant velocity in the real world and compare the results to a model of constant velocity in the VPython computer program. For my experiment, I used a pool ball as the system and rolled it across a felt pool table, but after analyzing the results of my experiment, I saw the ball was not at a constant velocity. The clip starts once the ball has reached its constant velocity. The origin starts at the center of the ball at time equals 0 with the x-axis horizontal and the y-axis vertical. The calibration tool marks the diameter of the ball, which is 5.715 times 10 to the negative 2 meters. The tracker records the position of the ball in each frame for the duration of the clip, which is 1.083 seconds. The program takes the data and stores it in the bottom right. Using the fact that velocity equals a change in position over the change in time, I found that the velocity for the first two data points was negative 0.6 meters per second. At data points halfway through the time period, the velocity decreased to 0.54 meters per second, and at data points at the end gave a velocity of 0.51 meters per second. The info that is stored allows us to create a graph later on. In my model, I changed the initial starting position of the ball and the initial starting velocity of the ball to match what we found in the experiment. I also set time equal to 0 and delta t equal to 0.01. The next three lines of code are important for creating a graph of the model later on, and we'll come back to those in a minute. This while loop is used to calculate the ball's velocity and its change in position over time. Ball.vel takes the initial velocity of the ball and adds it to the net force divided by mass multiplied by the change in time. The ball.position takes the initial position of the ball and adds it to the product of the velocity and the change in time. The output file, pythontest.csv, stores all this data and allows us to use it to make a graph. The data collected from the experiment and model allowed me to create this graph. The model data shown in red predicted a constant velocity, which shows up as a linear line, while the experimental graph is not linear, meaning the actual experiment was not at a constant velocity, and shows that the ball sped up in the middle of the experiment, then slowed back down. I believe this is because the net force on the predicted path is for sure 0, while in the experiment it is not. In the experiment, the ball was rolled but not at a constant velocity, and had other forces from its surroundings acting on it, while the prediction from the model had no other forces acting on it and had a net force of 0. In conclusion, I saw that my experimental data did not match the data from the model. In my experiment, the object was not at a constant velocity. In order to figure out why it was not, I would need to calculate the actual net force for the experiment.